Okay, let's dive right into this explainer and absolutely transform how we tackle recording motion in Cambridge IGCSE physics. Listen, we see the exact same thing happen year after year. Let me paint a picture for you. We have two typical students taking the syllabus 0625 exam. Let's call them Alex and Sam. Now, Alex is the kind of student who overloads every single answer with raw physics facts. Alex memorizes the textbook word for word, but offers absolutely no analysis. Then you have Sam. Sam is always rushing against the clock, constantly missing the specific command words the examiner is looking for, and losing easy marks as a result. If you've ever found yourself staring at an exam paper, knowing the facts like Alex, or rushing like Sam, and struggling to put those thoughts into the right words to get full marks, you are in exactly the right place. Today, we are prioritizing bold application and solid structure over simple rote memorization. We are taking those raw physics facts and turning them into top-tier, structurally perfect answers.
A strong mastery of physics begins with this exact, incredibly simple question. Before we even touch a formula or try to decode a complex definition, ask yourself this one thing. Why do we care? Seriously, what does recording motion actually do for us in the real world? By answering this first, the whole concept suddenly feels necessary rather than just some decorative formula you've been forced to memorize. It shifts your brain away from passively recalling text like Alex does and moves you into actively solving a problem. Every physical effect, every measurement, and every prediction we make in kinematics comes back to this. Once you grasp the why, the how becomes a whole lot easier.
Here is our ultimate blueprint for today. First, the hook. Why motion matters outside the exam hall. Second, the application-first approach. Third, the safest method exam strategy to structure your answers perfectly. Fourth, we'll run through an interactive workshop to fix common exam weaknesses. And finally, I'll give you the ultimate memory prompts. Let's map out exactly how to get from being confused about motion to becoming a highly confident exam taker.
Let's kick things off with Section 1, the hook, why motion matters. To truly understand the physical world, we absolutely have to look outside the classroom walls. Notice how incredibly broad the applications are here. Recording motion isn't just about rolling trolleys down wooden ramps in a dusty school lab. It appears literally everywhere. It's in complex engineering and transport networks. It's the core of vehicle safety systems. Think about how crumple zones and airbags rely on precise calculations of deceleration. It's in energy systems, communications, medical technology, and even astronomy, tracking the movement of celestial bodies. Now, what's really interesting here is that a top-tier physics student can look at this list, name at least one of these real situations, and accurately explain why the physics helps us predict or improve outcomes. That is the exact level of application Cambridge examiners are looking for. Oh, and before we continue, subscribe to our YouTube channel, Ace the Exams, at acexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving on to Section 2, the application-first approach. This is where we start fixing those flawed answers. To build our exam answers properly, we need a reliable framework. We need a method that moves us smoothly from everyday language straight into formal, high-scoring physics vocabulary. Think of this 4-step walkthrough as your fundamental strategy, similar to the Peel framework you might use in English but tailored specifically for science. First, you must identify the exact quantity or phenomenon. Are we talking about velocity, acceleration, or displacement? Second, state the relationship involved. This is your formula or your core principle. Third, explain the underlying physics clearly. Tell the examiner why it's happening. And fourth, connect it directly to an observation, an experiment, or a real device. This step-by-step sequence ensures your reasoning never gets lost. You are essentially building an unbreakable bridge from a basic concept to a real-world application, step by logical step.
So, the absolute most crucial point of this entire explainer is right here. Whether we are looking at recording motion, fields, forces, particles, circuits, or waves, you must insist on a clear cause and effect chain. This is exactly where Alex goes wrong. Examiners do not want to see a brain dump of isolated, random facts just dropped onto the page hoping something sticks. They want to see your logic. They want to see that you understand how A physically causes B, which ultimately results in C. If you can articulate the cause and the effect, your mark potential shoots straight up to 100%.
And keep in mind, this cause and effect logic applies heavily to visual data too. If your exam question involves analyzing graphs to record motion, do not just describe the picture. You must explicitly stress what the slope, the area under the line, the direction, or the shape of the curve means physically in the real world. A slope isn't just a slanted line on a grid. It represents a physical rate like acceleration or velocity.
The area isn't just a geometric shape you're shading in, it's the actual physical distance traveled. Always, always translate the visual data into physical reality. Now for Section 3, the safest method exam strategy. Let's see how all of this builds into an ultimate framework. We're taking that application-first mindset and building it into the absolute safest, most reliable framework for structuring your written answers to maximize your marks. Meet the DREA framework: definition, relationship, explanation, application. When you are faced with a heavy structured question, this is your secret weapon. Start with the definition of the core concept. Then move to the mathematical or proportional relationship. Follow that up with a clear explanation of the physics behind it, and finally, finish with the application to the specific scenario given in the exam question. It is clean, it is comprehensive, and it systematically hits every single assessment objective the examiner is grading you on. I need you to memorize this concept, because using the DREA framework guarantees that you aren't just reciting facts like a textbook. It proves you are genuinely applying physics to solve a unique problem. The Cambridge marking schemes consistently and generously reward students who can demonstrate that dual capability. They want to see you say, I understand the underlying theory, and I can seamlessly apply it to this specific, unfamiliar situation you've given me. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, let's jump straight into Section 4, fixing common exam weaknesses. This is going to be a fast-paced, interactive workshop. We're going to look at some classic mistakes made by students like Alex and Sam and transform them live.
Welcome to challenge number 1, the data scan. Let's look at this direct side-by-side contrast. On the left side, we see a student who has just written the correct formula down. It's a start, sure, but it is totally incomplete. You are leaving marks on the table. Now, look at the right side. This is the masterclass. This is writing the correct formula and explicitly explaining all the variables. This brilliantly illustrates our first common trap. Never ever just drop a naked formula on the page. You must always define the variables to show the examiner you actually know what those letters represent in the physical world. V isn't just a letter you memorized. It is the final velocity.
Now for challenge number 2, find the flaw. A second major weakness, and this is classic Sam behavior, is quoting a process in total isolation. You might rush through and write down the name of the process perfectly, but if you stop there, your answer is deeply flawed. Instead, as we see on the right, you need to be linking that process directly to the resulting physical effect. This goes right back to those vital cause and effect phrases we discussed earlier. You need to write, this process occurs, which causes this specific physical effect. That tiny addition is the difference between an average grade and a top-tier grade.
Finally, challenge number 3, speed writing. Let's talk about examples. Don't just lazily drop a real-world example into your answer and assume the examiner will do the heavy lifting to make the connection for you. If you mention something like vehicle safety systems as seen on the left, that is not enough. As we see on the right, you must explicitly show exactly why that application follows from the physics you just explained. For instance, explaining precisely how increasing the time of a collision decreases the impact force. You have to connect the dots for the examiner. Never leave them guessing.
We've reached our final section, Section 5, Memory Prompts.
To ensure this DREA blueprint really sticks with you when you finally sit down in that quiet exam hall, I want you to visualize these 4 specific revision prompts. Treat this as your mental cheat sheet. Whenever you are studying any recording motion concept, run through these 4 questions. Number 1, what is the core idea? Number 2, what changes physically in the system? Number 3, what specific mathematical quantity or graph visually shows it? And number 4, where is it practically used in the real world? If you can confidently answer these 4 prompts out loud for any topic in the syllabus, your knowledge is totally secure. You are perfectly positioned for both the rapid-fire short-answer questions and the heavy-duty, high-mark structured questions.
I will leave you with this ultimate test of your mastery. Look at the challenge on the screen. Can you confidently string all of those pieces together right now? Can you define it, state the rule, explain the chain, and apply it to real life without hesitation? If you can, you are well on your way to absolutely crushing the 0625 syllabus. If you hesitated even for a second, you know exactly which part of the DREA blueprint you need to revisit. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Keep applying these structures, keep thinking about cause and effect, and I'll see you in the next explainer.